and but standing and you watch Mr. Baltan that to the video I will teach you how this is a part 11 half this is about the tar. With this video I will show you how you can make that human following the boat. So part 1 I made assemble the tar. This part I assemble this. Second part I made a obstacle avoidance boat. 3 Wi-Fi control tar and part 5 light following the boat. 5 made IR control remote control tar and part 6 made clap control. Part 7 Bluetooth control tar. Part 8 light following tar. 9 I made a joystick control tar. Part 10 I made a accelerometer control or a gesture control, and you can hear some musical noise since I was sitting in the near them the main road that side musical sound, that's why. Sensor which contain 3 pins, 5 volt ground data pin, output pin, digital output pin, 5 volt ground and 5 volt output and ground pin. Output are digital output. So 5 volt ground to ground of the Arduino, and there we connect pin number. Output pin is connected to a digital pin 2 of the Arduino. Digital pin 4, 5, 7 and 9 are motor pins which is connected to the motor driver. Input terminal. And motor driver 5 volt ground is powering by driven by Arduino 5 volt ground to ground, plus this motor driver is L298 and motor driver. So this motor driver have external pin for separate motor power which transports 5 to 36 volt. So in case my motor is 5 volt motor, so I will connect this pin also with 5 volt pin of the Arduino. And this is a wire. This wire is contained 2 USB cable which I chop the middle. It's 4 wires, green, white, red, black. Green, white for data transferring we need red and black. That for positive, black for negative. That is connected to the 5 volt line, and black is connected to a ground pin, which is common to for this motor driver L298N plus Arduino plus PIR sensor are common to that. This motor driver have 2 pins, supply pins 5 volt plus fixed to 5 volt and 5 to 35 volt, which are big common via this jumper and this potentiometer. This potentiometer and jumper. Jumper contained in the top position marks LH, and these are 3 pin adder. So we can select single pulse mode or multi-watt pulse mode. If we put middle jumper L and middle pin, it will give multiple pulses, and output when any motion is detected once other pin, it will only give H point, it only will give a single pulse when human is detected. So I will set H pin or H side, which means it will only single pulse output. And these are the 2 knobs here. Is the delay knob and sensitivity adjustment. Delay knob I will set minimum, but still it will take some delay. So person will come and it will go few steps away, then the bots come back follow it. I don't know why it's do this, since I will this programming side is programming. I will also set the no delay, plus I also set the minimum delay of this, or minimum delay set by this setting this knob such a way it will give minimum delay, but its minimum delay is also 5 or 3 or 5 seconds. So meaning if the person is running, it will after the run person running after the 3 or 5 seconds it will run. And this is a sensitivity knob, adjustment knob, which I right now sets low sensitivity. So if a human is away too much, it will then not follow it, or it's then not put in false reading like sunlight or anything. So that's why sensitivity, low sensitivity, and delay is also lost. So it lost delay is minimum 5 setting delay, 3 setting delay minimum, maximum delay is 2 to 3 minutes. This it may vary depending on which type of PIR sensor you use. This PIR sensor model number HC-SR 501. Now it's time for demo. We Now we can run this star and now we can see when I put running this star is running, we can little bit port up, since this is a three-wheeler car. So first wheeler is a tester wheel which is rotate 190 degrees, and this is a free wheel, so we cannot run at any motor. So that's why this wheels will spin the one direction. Since this is a free wheel, it will rotate any 190 degree angle. So that's why it will need to straight up every time. Since this is my car is three-wheeler car, there is another variant which is a four-wheeler car. That four-wheeler car works very well with this way. In this project, or the human following motion sensing project, but this is a three-wheeler car. So this is a tester wheel, three-wheel, third wheel is a tester wheel or free wheel, rotate unnecessary directions. We need to straight up, and although it works very well, it is working with a human motion only. If you can see in the video, same way it will run. Only we can need to change the front wheel direction, which is a tester wheel, and then it automatically follow human with some distance, and then it follow. Now we can explain a code in the laptop screen, and first we can see the demo here. When those forward, it will follow them, and now those to the laptop screen and then show. Now those system screen. Now explain a code of this PIR sensor control robot or motion sensor motion robot sensing robot. PIR pin equals to PIR sensor output pin connected to Arduino pin 2 digital 2. Motor set up constant into motor 1 pin 1 equals 4. So these are 4 motors pins. It's the space, it's extra space. So 4 motors. Motor 1 one pin is connected pin number 4. Motor 2 1 pin 2 is connected to the pin number 5 of a digital 5 Arduino. Motor 2 pin 1 is connected to the pin 7. Motor 2 pin 2 are connected pin number 9 of the Arduino. These are digital pins. Bool human detected equals false. So it is a boolean function. By default it will false. Int speed equals 200. So it is a 200 speed, which is a maximum contains 0 to 255 speed, but we put 200 speed, so it will not write anything. Baud rate 9066 for serial communication for troubleshooting process. This is a baud rate, which baud rate 9066 baud rate Arduino and communicate with the computer. So in case we can troubleshoot this using serial monitor so that's why we put this command. Otherwise, if you cannot put this command, it still be working, but it will not work as serial monitor. Pin function, pin mode, PIR pin input, pin mode, motor 1, pin mode, motor 2, pin mode, motor 1 to pin mode, motor 2, pin 2, both are output. Only sensor pin will be input, other motor, all motor 4 pins are output, defined as output. In the while loop, if PIR value equal digital read PIR value, it will read a digital value for PIR sensor. If PIR value equals I, human detected equals to boolean function, which is previously it false. Like after human this pins PIR output those I, it will those two condition those two. Shape print human detected else human detected it false. Human detected it was false. Then if human detected move towards human, else stop report. If and then it will put in the function which is known as wide move towards human, which function are the digital force. I mean digital right motor one pin one low, digital right motor one pin two I, digital right motor pin motor two pin motor two pin one low, digital right motor two pin two I. So both motors first two pins are low and remaining two pins I, so it will work in forward direction. And else there's sensor cannot detect anything else. Why stop reverse? It is other function. It will run it this function. Put all the digital pins, digital right pins to low. Four pins are both two motors are low, meaning motor will stop. First line we put a define sensor pin, which pin is a sensor pin for getting the signal from sensor. This is a digital pin, pin 2, because my DPIR sensor is digital output sensor, digital sensor which gives digital output. And then we define four motor pins. So I use two motors. Each motor contains two pins, total four pins, which are 4, 5 for one motor, 7, 9 and for other motor. So why I not use 6 and 8? Because my Arduino 6 and 8 pin 8 is not working for some problem. So that's why I use this. Then we made a condition, which condition normally we set the false. Then we set the speed, which is 200. Then we in white setup we set the baud rate for troubleshooting process that pair in with system.
Sensor pin defined as an input and motor pins are defined as an output.
In the white loop we read the value for PIR, the signal for PIR sensor, and then this command checks whether the sensor signal is high or low. If human is detected, then its signal is high. If signal is high, this condition will be human detected. Condition will I mean true. Once true, see print human detected for no for person in troubleshooting procedure. Sensor is detecting anything human or not, and else if human is not detected, then it was false, which this conditions which is already true when human is detected, then it's those false if human is not detected, and if human is detected, it will go to the human, to the human, and else if no human is detected or signal pin is low, it will stop the robot. And this procedure wide moves towards human is a function which function is consistent of motors. When this function is run, meaning when a human is that this function is run, it will put the two motor four pins, two pin for high or two pin for low. Each motor one pin and other motor one pin to high, other first motor to second pin and second motor second pin to low. That is motor rotates forward direction and it follows a person or human. Or if human is not detected, then this white stop reboot function that run, this function put all the motor four pins to the low, tie to ground. This motor will stop and it will not spin the in both any direction. And this is when we can next to you.